Okay, so you know how we all really need to manage external access to our Kubernetes applications, right? I mean, Ingress NGINX, that's like the go-to tool for a lot of folks out there. And while it seems some recently discovered security flaws have kind of turned it into a potential backdoor. Yeah, we're calling this whole thing Ingress Nightmare, and we're going to really dive deep into exactly what this all means for cloud security today.
So what's really fascinating here is like the severity and just how widespread these vulnerabilities are.
Yeah.
You were talking about unauthenticated remote code execution, which basically means an attacker doesn't even have to like log in to potentially take over your whole Kubernetes cluster. Yeah, it's about as critical as it gets.
Yeah, for sure. Now, for those of you out there who are managing applications on Kubernetes, you're probably pretty familiar with Ingress NGINX already, right? But just to kind of level set here, think of it like a smart gatekeeper, the one that directs traffic from the internet to the right services inside your cluster. And it's incredibly popular. I mean, you don't get over 18,000 stars on GitHub for nothing, right? Over 40% of all internet fake Kubernetes deployments are using this thing. It's a pretty fundamental piece of the puzzle for lots of cloud infrastructures out there.
And it's that ubiquity that really makes these vulnerabilities so significant. Like we said earlier, right? We're talking about remote code execution,
Yeah.
RCE. And the Common Vulnerability Scoring System, that's the CVSS, they give this thing a near perfect score, like 9.8 out of 10. And that basically means this is extremely severe. Bottom line, a successful exploit could let an attacker get unauthorized access to every single secret you've got stored in your Kubernetes environment. And that's across all namespaces. So essentially, they could have complete control over your whole cluster.
Yeah, that's not good. All your sensitive data, configurations, everything, all potentially compromised. Yikes.
Hmm.
Now, these vulnerabilities, they have some very specific names, as they always do. So I've got CVE 2025-10907, CVE 2025-9098, CVE 2025-24514, and CVE 2025-1974. The folks who discovered these are, yeah, the sharp folks, as always, over at Wiz Research. Interestingly enough, they found another one, too, CVE 2025-24513. But thankfully, this one doesn't actually lead to RCE.
Right. And if we kind of zoom out and look at the bigger picture here, what Wiz Research found really does paint a pretty concerning picture. They estimate that something like 43% of all cloud environments out there are vulnerable right now. Their analysis actually pinpointed over 6,500 publicly exposed clusters. And these have these vulnerable Ingress NGINX controllers just kind of sitting out there. And you know what? This even includes some Fortune 500 companies. So it's pretty clear that the risk here is huge, and understanding this is crucial for everybody.
Okay, so let's get down to the nitty-gritty here. How does an attacker actually exploit this thing? Where's the entry point? What are we looking at here?
So the attack vector, the way they get in, is through the admission controller component of Ingress NGINX. Now think of this admission controller like there's another gatekeeper, right? But this one intercepts requests that are going to your Kubernetes API. And it does this to enforce policies and make sure configurations are correct before they actually get applied. Its job is to validate these incoming ingress objects. And these ingress objects are basically the rules that define how external traffic is supposed to be routed, where it should go. The important thing here, though, is that these admission controllers, they're often accessible over the network without needing any authentication at all. So no ID check. And that makes them a prime target for bad actors.
Okay, so hold on. If the admission controller isn't checking for credentials or anything like that, what happens when somebody sends it something a little bit, well, unexpected?
All right, so when the Ingress NGINX admission controller receives an ingress object, it takes that object and uses it to build and then test the NGINX configuration. The way it does that is by running this command called inject-t. Now, the big flaw that Wiz Research uncovered is that during this validation phase, during this testing phase, it's actually possible to inject your own arbitrary and potentially dangerous NGINX configurations.
Yeah.
And you can do this just by sending a specially crafted ingress object straight to the admission controller.
So you're basically like tricking the system into validating your malicious code as if it were legitimate. That's pretty clever, although obviously also very dangerous. So what happens then? What's the end result if somebody manages to successfully inject this bad configuration?
So if they get that malicious configuration in during the validation process, it's going to trigger remote code execution. And this happens directly on the Ingress NGINX controller's pod. That's the container where the controller is actually running. What makes this even worse is that the admission controller usually runs with elevated privileges, and it has network access inside the cluster. So it's a perfect recipe for privilege escalation. By getting code execution on that pod, an attacker can potentially then get access to all the secrets that are stored in your Kubernetes cluster.
You mentioned earlier that getting that initial foothold inside a cluster's pod network, it's not always a huge challenge. Could you maybe expand on that a little bit? Why does that make this whole Ingress NGINX vulnerability even more worrisome?
Yeah, sure. So Wiz Research, they really emphasize that, containerization is great. It provides some security, but it's not a perfect wall, right? There have been lots of container escape vulnerabilities discovered over time. Plus, on top of that, lots of web apps running on Kubernetes are vulnerable to server-side request forgery, or SSRF. And an attacker could use one of these vulnerabilities to get that initial entry point into the pod network. And then from there, they can pivot and exploit this unauthenticated admission controller. So basically, these Ingress nightmare vulnerabilities become much, much more dangerous when you've got other security weaknesses already present in your Kubernetes environment.
Right. So it's like a chain reaction. One small compromise can lead to a total system takeover through these Ingress NGINX vulnerabilities. Okay, let's break down some of the specifics of these CVEs now. The first one you mentioned was CVE 2025-24514, the authorial annotation injection. Walk us through that one. How does it work?
So this one's interesting because of how the authoric parser, which is what handles all the authentication stuff, processes this thing called the authorial annotation. Now, this annotation is supposed to specify a URL for like an external authentication service. The problem is the URL that's provided in the authorial annotation gets put directly into the NGINX configuration without any kind of input sanitization.
So no checks at all. That seems pretty risky to me.
Yeah, exactly. Because there's no filtering of what gets put in there. An attacker can create this malicious authorial annotation that doesn't just have a regular URL. They can inject all sorts of extra NGINX directives in there.
For example, they could use something that looks like this, http.example.com hashtag injection point. And when that NGINX configuration gets built and tested with that ngx-t command, that malicious code is going to get inserted right in there. And that gives the attacker a way to run their own commands during that validation step.
Okay, that's surprisingly simple and kind of terrifying at the same time. So how did they fix this in later versions? Well, the good news is that starting with version 1.1.1.0 of Ingress NGINX Controller, they added stricter rules. They use regular expressions to validate all the annotations, and that includes the authorial. So if you're running 1.1.0 or later, you should be protected from this particular CVE.
Okay, that's good to hear. So what about the next one? CVE 2025-10 and 97, the auth teles's match dash annotation injection. It sounds a little more complicated.
Yeah, this one's a little more involved. The authorial's parser handles this annotation called off-telos match CN, which is used to match the common name, the CN, of a client certificate when you're doing TLS authentication. Now it uses this thing called a common name annotation validator, and that enforces two conditions. The value has to start with CN, and the rest of it has to be a valid regular expression.
So there were some safeguards in place at least. How did the researchers get around them?
Yeah, so even though it looked pretty restrictive, Wiz Research found a way to sneak past these checks and still inject arbitrary NGINX configurations. They did this within the if block that's linked to the client's variable. Now that variable, that holds the client certificate's distinguished name by carefully crafting the auth-tls match CN value, for instance, using something like this, CNN global injection, hashtag #TON. An attacker can break out of the normal if statement and add their own custom NGINX directives.
Wow. Using the expected format to sneak in malicious code, that's ingenious and concerning all at the same time. But wasn't there also something about having to specify a TLS secret when you use this annotation?
Right, that's an important detail. For the auth-tls match CN annotation to even work, to even be processed by the Ingress NGINX controller, you have to provide this other annotation. It's called njink.ingress.kubernetes.io auth-tls-secret. And that annotation, it points to a TLS certificate or a key pair secret inside your Kubernetes cluster. And here's where the potential for things to go really wrong comes in. The service account that the Ingress NGINX controller uses, it often has permission to access all the secrets within the cluster. So that means an attacker can specify any valid TLS certificate or key pair secret. They don't even have to own it legitimately. They can just use it to trigger their malicious off-tls match -n annotation.
That's a huge privilege escalation problem. You mentioned some examples earlier of some commonly available TLS secrets. Could you maybe refresh our listeners on what those were?
Absolutely. A lot of managed Kubernetes services come with default TLS secrets that are just kind of sitting there in various namespaces. Some of the ones that Wiz Research pointed out include kubesystem connectivity certs, kubesystem Azure webhook server cert, kubesystem those load balancer webhook tells, and a whole bunch of others that are scattered across different namespaces like Calico System, Cert Manager, and Linkerd. And because the Ingress NGINX controller can often just access all these secrets freely, it makes this vulnerability a lot more serious. It means an attacker could use existing secrets that seem totally innocent to get that initial foothold.
That really highlights just how far-reaching the consequences of exploiting this single annotation could be. Okay, moving on. Let's talk about CVE 2025-1098, the mirror UID injection. This one sounds different because it involves the Ingress object's unique identifier.
That's right. The mirror annotation parser, it handles this traffic mirroring feature that lets you send a copy of incoming traffic to another service for things like testing or monitoring. This parser, it takes the unique identifier, the UID, of the Ingress object and sticks it directly into this location, mirror source variable inside that temporary NGINX configuration.
And because the UID is a standard Kubernetes metadata element, not a specific annotation, it bypasses those annotation-specific validation rules.
Right, you got it. Because it's a core Kubernetes metadata field and not something a user defines, it doesn't go through the same input validation checks that annotations have to go through. And this little oversight, this lets attackers inject whatever NGINX configuration directives they want. They just manipulate the UID field in their malicious Ingress object, and they're good to go.
So no complex workarounds needed for this one. Just straight up injection by changing a basic Kubernetes field. That seems almost too easy and super dangerous. All right, last but not least, we've got CVE 2025-1974. The description mentions NGINX configuration code execution. How does this one connect to those injection vulnerabilities we talked about?
All right, so this is where those earlier CVEs get really powerful. Those let you inject NGINX directives, which are like configuration commands, but this vulnerability shows you how to actually run code on the system. Now, the researchers first tried using this load module directive, which is a standard NGINX feature for loading shared libraries, but they found out that load module can only be used at the very beginning of the NGINX configuration file. If you try to inject it later, it just won't work.
So that first attempt hit a wall, but they found another way, right?
They did. They discovered that the Slengin directive, which is part of the OpenSSL module in NGINX, can also load shared libraries. The key difference is that Slengin can be used anywhere in the NGINX configuration, so that makes it perfect for taking advantage of the injection points created by those other CDEs.
Okay, so now they can load a shared library wherever they want in the configuration, but how do they get that library onto the pod's file system to begin with?
All right, so this is where things get a little tricky. They use a clever trick with NGINX's client body buffering. So when NGINX processes incoming HTTP requests, if the request body is bigger than a certain size, usually around 8 kilobytes by default, it saves that body to a temporary file on the pod's local file system. The researchers realized they could send a huge HTTP request directly to the Ingress NGINX controller and put their malicious shared library right inside that request body.
But doesn't NGINX delete that temporary file pretty quickly after it's done with the request?
Yeah, it does, and that seems like a problem at first. But even after the file is deleted, the operating system still keeps an open file descriptor pointing to that deleted file. And you can access these open file descriptors through the procfs file system in the Linux kernel. So even though you can't see the file in the regular file system anymore, there's still a reference to it. And to make sure this file descriptor stays open long enough for them to use it, they can set the content length header in their HTTP request to a value that's bigger than the actual request body size. That makes NGINX wait for more data, which keeps the connection open and the file descriptor alive.
Wow, so they basically found a way to keep a phantom file alive, even after it's deleted. Pretty impressive. So the last step is to point the Slengin directive to this hidden file in the procfs file system.
Exactly. The whole attack works like this. First, they upload their malicious shared library by sending that big HTTP request to the Ingress NGINX controller. That takes advantage of the client body buffering. Then they send an admission review request that's got one of those directive injection payloads from the earlier CVEs. And inside that injected directive, they use Slengin to load the shared library from that procfs path. Now, Kubernetes pods, especially minimal containers, don't usually have a ton of processes running, so it's actually not that hard to guess the right process ID, PID, and file descriptor FD number. If they get it right, their malicious shared library gets loaded into the NGINX process and they get remote code execution on the Ingress NGINX controller's pod.
That is a seriously complex and alarming exploit chain. So for our listeners out there who are running Ingress NGINX, what should they do right now to protect themselves? What are the immediate steps?
All right, first things first, you got to figure out if you're even using Ingress NGINX in your Kubernetes clusters. You can usually do that by running this command: kubectl get pods all namespaces selector app.kubernetes.iona ingress-nginx. And if you are using it, the absolute best thing you can do is update to the latest versions. That means version 1.1 and version 1.10.5. These versions have the fixes for these vulnerabilities.
Right. Keeping software up to date is always, always important. But what if somebody can't upgrade right away? Are there any temporary things they can do to mitigate the risk?
Yes, if upgrading isn't an option right this second, there are a couple of really important things you need to do in the meantime. Number one, you got to make absolutely sure that the ignition webhook endpoint for your Ingress NGINX controller is not exposed to the public internet. Wiz Research, they actually put out a nuclei template you can use to check if your admission controller is publicly accessible. And number two, set up some strict network policies in your Kubernetes cluster. You want to lock down access to the admission controller as much as possible. Ideally, only the Kubernetes API server should be able to talk to it.
What about just disabling the admission controller entirely? Is that a viable option, at least temporarily?
So that's a pretty drastic measure. And it should only be a last resort if you absolutely can't upgrade right away. But if you have to, you can disable it temporarily. Now, if you installed Ingress NGINX using Helm, you can usually just reinstall it with this flag: controller.admission_webhooks.enabled false. If you installed it manually using YAML files, you'll need to delete the validating webhook configuration named Ingress NGINX admission. And you also got to remove the validating webhook command line argument from the Ingress NGINX Controller containers deployment, or daemon set spec. But here's the really important part. You have to remember to re-enable the admission controller as soon as you've upgraded, because it's got some really important security checks in it. Disabling it takes those checks away.
So it's a Band-Aid fix, and you got to make sure you take it off as soon as possible.
Got it.
Now, it sounds like Wiz customers have some specific tools and resources they can use to deal with this, right?
Yeah, that's right. Wiz customers can use pre-built queries and security advisories in the Wiz Threat Center to find any vulnerable Ingress NGINX deployments they have. And their dynamic scanner, it automatically checks for publicly exposed admission controllers. Plus, their runtime sensor can spot potential attacks by watching Ingress traffic for any suspicious admission review requests or weird library loading activity.
This whole thing really brings up some bigger points about cloud security in general, doesn't it?
Absolutely. One big takeaway is that Kubernetes admission controllers, they're running in the background, but they can be a real attack surface if you're not careful. They handle all sorts of important validation logic, and they often run with a lot of privileges in the cluster. So if they're not properly secured, they're prime targets for attackers.
And it sounds like even the researchers were surprised by how complex the code in these controllers actually is.
That's right. The Wiz Research team, they specifically said they were surprised by how much code is involved in processing these configurations. And that complexity makes it more likely that there are vulnerabilities hiding in there somewhere. It really shows how important it is to follow the principle of least privilege. You got to restrict access to these internal components as much as possible. Ideally, they shouldn't even be accessible from inside the cluster, and definitely not from the public internet. And it looks like the lack of a strong least privilege design in some common configurations is a big part of why these vulnerabilities are so potentially dangerous.
It's also interesting that these weren't the only vulnerabilities that Wiz Research found when they were digging into Ingress NGINX Controller. Sounds like there might be more security alerts coming down the pipe.
Yeah, it seems that way. Their statements suggest they found some other vulnerabilities too, so we all need to stay on top of things and watch for any future security announcements about Ingress NGINX and other important Kubernetes components.
And one last thing that really stood out to me was their point about the nginx xt command. It sounds like even just testing a configuration can lead to code execution in this context. That seems like something that should be better documented by the NGIN project itself.
I agree. The fact that simply testing a configuration can trigger code execution is a big deal, and it definitely needs more awareness and clearer documentation in the NGINX community. Developers and users need to know about this.
Before we wrap up the main part of our discussion here, I think it's important to acknowledge the responsible disclosure timeline for this whole thing. It looks like Wiz Research worked closely with the Kubernetes and Ingress NGINX maintainers for quite a while to get these vulnerabilities fixed before going public.
Yeah, they reported it back in December of 2024, and the patches and public announcement came out on March 24th, 2025. That shows a real commitment to responsible disclosure and remediation from the open source community. It's good to see.
So the key takeaway for you, our listener, is this. There were some very serious unauthenticated remote code execution vulnerabilities in a very popular and essential piece of Kubernetes, the Ingress NGINX Controller. This whole Ingress nightmare situation is a wake-up call. We all need to stay informed about cloud security risks and be proactive about patching systems and using security best practices.
And that brings us to a really important question for you. What's the security situation like in your own Kubernetes environments? Are you running a vulnerable version of Ingress NGINX? If you are, you really need to look into this and start implementing those mitigation strategies we talked about today. Prioritize updates, set up strong network policies, and if you absolutely have to, disable the admission controller temporarily before you can upgrade.
And here's one final thought for you to chew on. We've seen how complex and powerful these seemingly internal systems like admission controllers can be. So what other hidden attack surfaces might be lurking out there in the world of modern cloud environments? It's a good reminder to think outside the box and always be reassessing the security, even the most basic components, the ones we might take for granted or think are just for internal use.
The Wiz Research team has done some fantastic work finding these vulnerabilities and working with the community to get them fixed. If you want to stay on top of this kind of critical cloud security research, I definitely recommend keeping an eye on what they're doing.
Thanks for joining us for this deep dive. Stay safe out there in the cloud, everybody.